Good morning all. I'm pretty certain that you wouldn't want to watch me opening socks and rum and raisin fudge. So let's have an alternative Christmas present opening where I open all these goodies which have been very kindly donated by Banggood.com. Let's start with the TSAT soldering iron. Let's unbox this. Now I'm only going to do an unboxing now because there's no point actually trying this out, because I'll be using this sort of alternating with the TS100 in numerous videos going forwards. So we'll just have a quick look at this. Now the first thing the first thing I noticed is that this is a very lightweight, slender item without it. Oh, there's the USB-C connector, and there's the, oh, actually I think we can remove that, and then we should be able to see the 3.5 millimeter, well, we can't quite see it, 3.5 millimeter connector, which is where the tip goes. This just has what looks like a stereo headphone connector, which I guess is sensible because they're fairly ubiquitous, aren't they? Now you may have seen this in a recent video, which was David Watts's crap badge, where I attempted to use this. Does that unscrew? Yes, it does. I attempted to use this, but the trouble is the bit supplied is this rather fat wedge chisel shaped bit, and it really wasn't suitable for surface mount work, hardly surprisingly. Let's plug this in. Unlike the TS100, this plugs in without any sort of retaining screw. But the TS100 was a good fit, and this is a good fit. They obviously decided there's no point doing that. And as well as the iron there, in this white box, there are some instructions there. In this white box, what do we have? We have a grounding strap. So there's a grounding point on here then, I guess, yeah. There we are, there's a little screw for attaching grounding. Now, I can't see the point of grounding. Why would you need to ground if you're running this from a power bank? I suppose if you're using this on a mains, but even a mains QC3 power supply is going to be galvanically isolated from any mains. I suppose it's for ESD, isn't it? Yeah, it's for ESD rather than any sort of mains issues. Okay, you might want to use that. Here is the USB-A to USB-C connector. This is silicone. This is extremely flexible, so that's going to be quite a pleasure to use. It's not going to get all tangled and twisted and all that kind of stuff. And here's the Allen key, the hex key, which for the TS100 is quite important that you keep it nearby. Yeah, I've got one over there, because that you have to tighten and untighten. Well, you probably don't. You probably needn't bother to tighten and untighten the bit. On this one, all it does is tighten and untighten the little screw that holds the ESD strap with crocodile clip and coily cable. So that's not quite so important, but it's probably the same size as the TS100 Allen key anyway. Oh, there's one other thing in here, which I'm not going to use. It's a USA multi-voltage, I would guess, to 5-volt USB, but coloured orange, so QC3, Quick Charge 3, compatible power supply. So I have briefly used the TSAT, and it's just occurred to me why it makes perfect sense that this is a different connector to the TS100, and that is because this, I think, is a 60-watt iron, so the resistance of the element is probably different. I'd have to do the maths for that. This is only an 18-watt iron because it only draws 9 volts from the quick charge USB port at a maximum of 2 amps. So this is 18 watts. That's the same as my old Antex CS18 iron, so it's not going to have the grunt that this one has for things like massive areas of copper on PCBs, or if you're soldering lugs to big pieces of metal, that sort of thing. So I imagine that the TS80 is very similar to use to the TS100. Let's put these back in. Just that it's got less power. It will therefore take slightly longer to warm up, and it will be a little less capable on areas where the heat is going to get sucked out quickly. I'm going to buy some smaller sized bits for this iron, so you probably won't see it until those come in, but then I'm going to be using both of these irons in my general soldering work in videos, and so over time we can work out which feels best. Probably both very similar is my guess. Right, next let's look at this, which is fairly obviously a torch, and this, which is the battery that powers it. So let's just open the torch box. Now I'm not going to do a review of this torch right now, and when I do a review of this torch, I'm going to do it on my reviews channel, because that's what it's for. So here it is. It's one of these sort of tactical styled torches with lots of grippy areas and so on and so forth. What was particularly interesting to me about this flashlight, let's see if I can undo the battery compartment, is actually the battery. So let's move on to the battery, because this looks like an 18650, but it's not. It's a 21700. Let's put it next to an 18650 to see the size difference. And there we are. It's slightly longer, so it's 70 millimeters long as opposed to 65 millimeters long, but of course the diameter is larger, so volumetrically there's a lot more space in here to store energy. And you can see that this one is marked 4800 milliamp hours. Now I have put it in the Litokala Engineer 300 battery charger and done a capacity test. Didn't quite match up to the 4800 milliamp hours. In fact, I might as well tell you now, it was 4100 milliamp hours in that charger. Now that charger can only discharge at half an amp, and this has ratings which are a bit higher than that. Max discharge 10 amps, max pulse discharge 35 amps. Now this is an IMR, and I've been looking up these codes because I wanted to finally get in my head what these codes mean. Apparently this means lithium for the I, bit strange, manganese for the M, and R, on some websites it's rechargeable and on others it's round, as in cylindrical. But yeah, these codes are very interesting. Let's come back to that in a moment. Let's just put that in the torch. Now there is something in here. Let's take it out. And it's a little adapter. So you can use an 18650 in here. You just put it in there, and this takes up the extra width and gives it that little bit of extra length. But of course you can put a 21700 in this torch, because this is a 21700 torch, and in it goes. I'll put the cap on, and I've no doubt it will work. Of course I have to work out the operating system. I hope that's the right way around. Oh, looks like it probably is. That's quite cute. And yeah, that torch works. But what was interesting to me was the 21700 cell format. Oh, this is quite fun. If you press and hold, it doesn't flick through brightness levels. It actually fades up. Well, that's quite bright. That's kind of lit up the whole room by shining that at the ceiling. But it also seems to give you some sort of visual feedback on the button. Let's see when it goes down to its lowest level. Yeah, you get sort of flashes which tell you that it's reached, I don't know, each end of the brightness scale or something like that. Neat. Now it's possible that my measured 4800 milliamp hours, my measured 4100 milliamp hours could increase a little once I've cycled this cell a few times. So I do think that this cell, this GTED or GTED or however that's pronounced, is probably not far off 4800 milliamp hours capacity. Now you certainly can't get that capacity in 18650s. In fact, realistically, I think 3400 milliamp hours on this lumen top, and this through night is also 3400 milliamp hours. I think realistically that's about the maximum capacity you'll get in an 18650, so you would expect more in a 21700. I think this is the cell that they use in Tesla electric cars, isn't it? But then we've also got to consider the trade-off between energy storage, so capacity, and the maximum current that you can draw on a continuous basis. So for example, if you allocate more space inside here to the chemical process, you can get more capacity, but then your electrodes will need to be thinner and take up less volumetric space. So you'll have less current that you can draw. So you have high capacity, low power cells. And then on the other hand, for things like electric power tools, you'll have lower capacity. There's less space in here for chemistry, and the electrodes are physically thicker, so that you can get more current through. So that's the trade-off. So from Battery University, which I can't show because it's copyright, we have a whole range of chemistries here. We have lithium cobalt oxide, which would be on the battery ICR, the C being cobalt. Lithium manganese oxide, I think it's an oxide. Oh, let me check that. Yes, lithium manganese oxide. So that's I for lithium, M for manganese, and R for either rechargeable or round. But then you get the more esoteric chemistry mixtures, lithium nickel manganese cobalt oxide. And this one down here, lithium nickel cobalt aluminium oxide. And then you get the 8, lithium iron phosphate. I think because it's an O4 it becomes an 8. I don't know chemistry. And this one is lithium titanate. So we've got titanium there and oxygen. Now the trouble with this is this long one here has so many letters in it that you can't do that in a 3-letter code. So actually this one became NMC just for the nickel, manganese and cobalt. LifePo4 I don't think has a 3-letter code. But then you get NCRs, and there's all sorts of different mixtures of these codes. So it started off with good intentions, showing whether it's a cobalt or a manganese chemistry, and then of course the system fell apart as we get these more esoteric chemistries. And it's almost certain that this cell, being a modern cell, isn't pure lithium manganese oxide. It's probably one of these more esoteric mixtures. I read somewhere that all modern cells are these more stable chemistries because these additional additives just make a more well-behaved cell than these 2 original chemistries. And I've just noticed on the other side of this Astrolux torch there is a rather nice charge port. It's a standard port. I mean, it's USB type B, but it's heavily recessed, and the little rubber bung it's got a little lip on it there, so that's going to make a really good waterproof seal, would be my guess. And that fits in there really nice. That's the best implementation of a cover over a USB port that I think I've ever seen. And the next item is this. Let's open this up, and I'm quite excited about this. I'll just cut all the wrapping off, because this is another supercapacitor board. That's interesting. They've tied a little that's silicon wire. They've tied a little wire across VCC and ground to ensure that this thing doesn't kind of charge up in transit and zap you. I mean, it's not a huge voltage because these are 2.7 volts and there are 9 of them in series. Oh, we need a calculator. 24.3 volts. So this is a sort of nominal 24 volt block, but this will be very interesting for use on my Muppet 2 because I can transfer energy from a sort of nominal 16 volt block of 6 supercapacitors to this nominal 24 volt block of 9. Now let's take a closer look at the, I know this is discharge, let's take a closer look at the protection circuits. Well, we appear to have, and we would have of course, 9 identical circuits. Now my guess is this is a MOSFET. Actually they've scraped all of the semiconductors very badly. You can read quite a lot of them. Why would they scrape them? I mean, this is a very well-known circuit. So I think MOSFET 6R8 resistor. Now you can see that the MOSFET and the resistor are in series across the capacitor. So as soon as the MOSFET turns on, of course, it puts this dump load across the capacitor to pull its voltage down. There's probably a voltage detector IC. There is an LED there, actually, D4 in this particular circuit. And it looks like they may have implemented a separate transistor circuit to turn the LED on. They haven't used my idea of just simply putting the LED across the big resistor, which works on 2.7 volt capacitors. No, it looks like they've implemented a separate switching circuit for the LED. So when I charge this thing up, it'd be interesting to see whether that comes on in a sort of analog sense or switches hard on and off in a digital sense. But nice to see that they've put those LEDs on here. All the previous protection circuit boards I've seen haven't had them, and I've had to add them. So yeah, pleased to see those. And the final Banggood item is this. It's a marine boat splash proof switch panel, and you can see, well, let's take it out of its box. It's a switch panel with 6 really nice rocker switches, integral lights. I believe you can get this 4 different colors of illumination. I went for the green one. And also on here is a little voltage monitor for 12 volt DC. Of course, this is intended for 12 or 24 volt in the sense that it is for boats, RVs, cars, trucks, that sort of thing. There's a 12 volt, that's quite well sealed, a 12 volt outlet there, cigarette lighter style. And this, I believe, is a dual USB. Oh, quite high current, that one, 3.1 amps. Is that each or across both? Don't know. And the voltage monitor actually is incredibly thin. Well, I mean, it can be, but yeah, surprisingly thin, that one. This one's quite deep, presumably for the buck regulator for these two 5 volt sockets. And this one's just deep because, it's deep, isn't it? You've got to put the plug in it. It comes all pre-wired, which is rather nice. This looks like, yes, I think we've got positive and negative for the 3 sockets, or the 2 sockets and the voltage indicator there. They can be commoned up with positive and negative. Now my guess is that this is positive and negative. Well, there has to be a supply to illuminate these LEDs, if they are indeed LEDs. I'm sure they are at 12 volts. And then we've got these switched outputs. You get 6 pre-made up leads for the switched outputs. So negative doesn't really need to be this massive thick wire, does it? Because that's only going to the negative side of the LEDs. The switching, I presume, is in the positive side. Positive in here, positive out on these 6. Negative, you'd have to wire separately. Interesting. Also supplied with lots of sort of self-adhesive rub-down symbols for various lights, heaters, and various other things, which I think is really cool. Those are all in white. There are also some sticky labels for various peripherals, cockpit lights, engine instruments, bait tank pump, and all that stuff. And there are some screws in there as well. But yes, this, as I'm sure you can guess, is for my 12 volt work zone. So back out into the 12 volt work zone, and you can see my wiring there for things like my light socket, but of course there's no switch on there. So the idea is to have this switch panel mounted somewhere. I'm not quite sure where yet, because it's quite deep at the back. I'm going to have to think about how it's going to work with these window panels, but yeah, I'm sure I can find a place. Well, even if I hang it up there, put a piece of timber across and hang it up in the roof area. Of course, you do get condensation on the underside of these roof panels, so I don't want that really dripping into all my electrics. But then this is splash proof. Now I've taken to removing the control panel from the end of the control panel cable to work almost like a security key. So without the control panel, this can't really be switched on. And in fact, that diesel heater is continuously powered up with 12 volts. It seems perfectly happy just sitting there, powered up with a missing control panel. And I'm pretty sure that my little buck converter there from 12 volts down to 5 volts, which is also permanently powered up, is entirely happy exposed out here, but under a cover. Let's just switch that on and check that these LEDs are still working and cycling through all their colors. Yes, they are. That's perfect. And so these are today's Postbag items, all very kindly supplied this time by Banggood.com. Thank you very much to Banggood. Thanks also to my sponsor, JLC PCB, and thanks to my Patreon supporters. If you want to become one, you can click this link here. Another couple of videos up here if you want to watch more of my stuff. And if you want to subscribe to this channel, click here. Cheerio!